Hey, welcome to our AP lab, the determination of the equilibrium constant for the iron thiocyanate complex. And in this lab, you're going to be using spectrophotometers to first establish a standard curve for the absorbance of the iron thiocyanate at 450 nanometers. And then you'll have some unknown solutions, and from those unknown solutions, you'll be able to establish concentrations from your known absorbance and from your concentration curve. And from that, establish or determine your equilibrium constant. This is page 169, and I want you to notice that these values add up to 10, these values add up to 10, but our SpectroVis cuvettes for our vernier spectrophotometers have a volume of 1 milliliter. So it doesn't make any sense to make too much solution. It's too wasteful. So what I'd like you to do is go through all of these solutions and have their values. Please go ahead and do that now. Pay really close attention to the difference between your reference value and your test value. Again, I'm on page 169, and your reference values have a different concentration of the iron nitrate and the potassium thiocyanate than the test solutions. What's interesting about this is that the concentration of the iron nitrate is so high here that it pushes the reaction entirely to iron thiocyanate. That is that deep red colored complex. So when you're doing your reference, you get to assume this is extremely in excess. Look at that, it's 0.2 molar, and this is 2/10,000ths of a molar for the potassium thiocyanate. So this ends up being the concentration for your reference solution of the iron thiocyanate. This is limiting, and Le Chatelier will teaches us that this entire reaction is pushed completely to products because of the extreme excess of this one reactant. All right, now that differs from our test solutions because we have a much more diluted iron nitrate. It's 100 times more diluted than our reference. And we have a much more concentrated potassium thiocyanate. It's 10 times more concentrated. And okay, so when you're making your reference, again in review, when you're making your reference solutions, this is the concentration of your product, which is your iron thiocyanate. That's that red complex. But when you're doing your tests, you don't know right away what the concentrations of your products are. Here's most of your gear. When in doubt, rinse it out. You're going to be using your pipettes back and forth, and this is your 10 mil pipette, this is your 5 mil pipette, or actually this is my bad, this is a 1 mil serological pipette, and this is your 5 mil pipette. Whatever you do, if you're going to change reagent with these, then rinse them out. For that purpose, we're giving you some DI water in a squirt bottle. The 50 mil beaker can be used for DI water, and then the medicine dispenser can be used for your reagent. One reagent at a time. Rinse this thing out and then go on to the next reagent. Rinse these if you use them, and then move on to the next reagent. We didn't want to overload you guys with too much stuff. Now notice you've got 2 cuvettes. One, use for your DI water for establishing your control, for zeroing your spectrophotometer, and then the other one is for your reagent. When in doubt, rinse it out. And I'm giving you chem wipes today because your fingerprints on the cuvette will mess with the absorbance. And so always keep your chem wipes around, wipe these off between each trial, between each zero. And the last thing you need to pay attention to is that the thiocyanate and the iron, they shouldn't go down the drain because of their low pH. And so I've got to treat these before we deal with the waste. And so over on this bench, I've got a waste bucket. Make sure that if you're rinsing any of your solutions, rinse them out into here so that I can treat that and follow King County hazardous waste protocols. All right, that's it. Good luck.